Now, what is nano encapsulation? So, encapsulation is, suppose here in figure, if you see, there is an active ingredients that may be your additives or other one that surrounded by a material encapsulation is done, and that encapsulating material is mainly nanomaterial. So, this one is called. So encapsulation is defined as the technology of packaging nanoparticles of solid, liquid, or gas, also known as the core or active within a secondary materials named as matrix or cell to form nanocapsules. So the core contains the active ingredients like drugs, perfume, biocides, vitamins, various additives, etc., while the cell isolates and protects the core from the surrounding environment. This protection can be permanent or temporal, in which case the core is generally released by diffusion or in response to a trigger such as pH or enzyme action, thus enabling their controlled and time delivery to a targeted site. So when that encapsulated form, then what happens? Sometimes we know that suppose if you taking drugs and drugs target, suppose that is liver related drugs, liver that used for the suppose curation of the liver disease. So in that case, we taking drugs which main target is liver. But sometimes what happens? Due to abnormality or due to different reasons, this your drugs is not reaching up to the target or that facing some disturbances. In that case, if we encapsulate that drugs and then that drugs is targeted, then its targeting possibilities is that increases. That means previously those which are facing disturbances for in reaching up to the target, now due to encapsulation that becomes easier and that easily reach up to the target and doing their activity. So that were now reasons to apply encapsulation in food industry. Why this encapsulation, nano encapsulation is done? What is their purpose? So there is a various purpose like reducing the reactivity of core material to outside world to order to protect it from degradation. Sometimes what happens, suppose if you take any that targeting material, drugs or other vitamins or other things, when that reach in our body, that interacting with other substrate and giving various byproduct that may be beneficial or harmful. So for preventing that reaction, this encapsulation is essential. Once that encapsulated, then that prevent their um, denaturation or degradation due to action of other component. Another modification of the physical characteristics of original material to allow easier handling. Again, sometimes various this component targeting material that are in different morphological form is available. So or their characteristic, physical characteristics or other things of that material is not suitable to target. So in that case, this encapsulation is done. Once that encapsulated, then that giving a specific shape to that one and that changing their some physical properties as we discussed that their optical, physical, chemical, that property changes due to that changes in product that people becomes familiar to act on the target molecules. Now for making an unwanted flavor or taste of the core for masking unwanted flavor and taste of the core material. Means sometimes that additives, as we know, said that used for different purposes. So in sometimes when that interact with other one, when reach in our body, their flavor or odor that may change. Or sometimes in environmental contact, their flavor, this one is changed to keep their flavor or odor or other thing, color intact that needs encapsulation. And that encapsulation is done by nanotechnological concept. Tailoring the release of the core material slowly over time or at a specific time. Again, the जो भी material that may be drugs or others that is targeting the substrate due to encapsulation, targeting becomes easier. That can target on the targeting molecules on time and also at a specific time. Another application of nano-encapsulation process is reduction of the evaporation or transfer rate of the core material to the outside environment. So as that keeping nano-encapsulation keep complete separation of the food materials from the your environment, and due to changes in environmental conditions, especially temperature, sometimes what happens, the moisture those which present inside the food materials that can be evaporated and cause drying of the same, and ultimately that deteriorate the quality of the food. Now, all material for encapsulation and characterization. A lot of substances of different types and properties may be used to coat or encapsulate solids, liquid or gases. होता है. However, only a limited number of materials have been certified for food application that generally recognized as safe. Grass. So there is a lots of nanoparticles, lots of things are available by which by using that one, we can encapsulate or coat the solid, liquid, and gases. But for food materials, all kind that not be used, there is a restriction to use the different numbers of the material which is called and that limited this one certified food application for that one is really called as generally recognized as safe. So that are glass. The majority of material used for nano encapsulation in food sector are biomolecules like carbohydrate, polymers, polysaccharides, which are the most proteins and lipids. They are grouped by hydrophilic and hydrophobic classes. So on the basis of nature of that biomolecules, mainly biomolecules is generally encapsulated, and purpose is to targeting that molecules up to their appropriate up to their appropriate target, and that is grouped in mainly on the basis of the affection towards water or not, that are mainly different types, hydrophilic and hydrophobic. So for both types of the food materials, different other different nanomaterials that can be used for encapsulation process. So carbohydrates are used extensively as raw material for the encapsulation of food ingredients due to their ability to form glassy solids that provide structural support to the wall material of the delivery system. Then the selection of the material must have the three important characteristics. जो भी material हम लोग encapsulation के लिए select करेंगे, for that there is a different three important characteristics that carries. First is excellent barrier properties, excellent film forming property, that is excellent wettability, phase transition point at which the matrix undergoes phase transformation. So different this one is used. Now, methods employed for manufacturing of nanocapsules. So, nano-encapsulation techniques uses either top-down or bottom-up approach. Top-down, bottom-up approach is top-down approach means the bigger one is breakdown into smaller form. So, from top to bottom, bigger one to smaller form, like various mechanical application, various sonication methods, we can decreasing the size of the bigger molecules in nano range. So in nanocapsulation, first method is top down. That means bigger molecules, like suppose if carbohydrate or proteins, which is macromolecules in size, that are bigger in size. So first target is to break down that one into a smaller form. That is called top down process. And bottom up process means in which in this process, the smaller compound aggregate together to forming the bigger one. In that case, the particles with size is too much lesser than the nano range. That is aggregate and converted into a bigger form in nano range. That is their size is increases up to in between 1 to 100 nanometer. that are bottom up approach. So these two approach is applies to develop a nano encapsulation techniques to develop nanomaterials and could be done in two ways, that is by physical means to form nanospheres or by chemical means to form nanocapsules. So here you can see there is an two techniques, top down techniques and bottom up techniques. In top down techniques mainly emulsification, solvent evaporation, ultrasonication, that techniques is used. And top down means you can see here like 1 millimeter or on micro range particles converted into nano range molecules. So that are molecules, monomers or ions and atoms that is formed. And in bottom up techniques, there is a various techniques like conservation, nano precipitation, inclusion, complexation, supercritical fluid techniques by which the smaller molecules converted into the bigger, a bigger one comes in the range of nanoparticles and forming the and using that one for the encapsulation process. So top-down approach involves the application of precise tools with the force that allows size reduction and shaping of the structure for desired application of the nanomaterial. So bigger one into smaller form. In the bottom-up approach, materials are constructed by self-assembly. जिसे हम aggregation भी बोलते हैं. Self-assembly and self-organization of molecules which are influenced by many factors including pH, temperature, concentration, and ionic strength. So there is a various physical method and chemical method is available for the formation of nano capsule material like spray drying, spray cooling, fluidized bed drying, extraction, lyophilization. That are the physical methods used for making the nano capsule. While chemical methods like conservation, liposome, inclusion complexation that are used for the making also the nano capsules. Now, nano encapsulation as an efficient delivery system. Nano encapsulation is generally estimated as percentage of compound included in the structure with respect to the total amount used in encapsulation. Nano encapsulation efficiency means mass of a compound encapsulated divided by total mass of compound used before entrapment into 100 means कितना यूज हुआ कितना लिया गया into 100. Application of nano encapsulation in food technology. The major area of current nanotechnology application, there is a wide application as we discussed that nano encapsulation process, preventing different types of contamination, increasing shelf life of the food, enhancing quality of the food, enhancing flavor, taste, all that one. So the major area of current nanotechnology application involves nano encapsulation of food ingredients and additives to provide protective barriers, flavor and taste making, masking, controlled release, and better dispersibility for water insoluble food ingredients and additives. A number of nutraceuticals and nutritional supplements containing nano ingredients and additives like vitamins, antimicrobials, antioxidants are currently available. These products typically claim enhanced absorption and bioavailability of nano side ingredients in the body. So due to that reasons, their absorptions, assimilation, digestion, all that becomes easier. That can easily targeting their target molecules and causing if your beneficial effect and enhancing their quality. So nano, which refers a range of 10 power minus 9 meter, and into emulsions are defined as the dispersion of two immiscible liquids. Emulsions is the solutions, kind of solution. So in which two dispersion of two immiscible liquids are mixed together and that forming emulsions with the spherical droplets forming the dispersed phase, whereas the liquid surrounding it from the dispersion continuous phase, or that is also called as dispersion mediums. So that are mainly the solvent and solute, which As these emulsions are mixture of two liquids, immiscible liquids, in which one liquid is used in the small concentration, a small amount that is called dispersed phase, and another are in excess amount that which is called either continuous phase or you can say that dispersion medium. So nano emulsions are emulsions that have very small particle size, have some unique character such as a small size, so that if size is small, that means increased surface area and less sensitivity to physical and chemical changes, making them ideal formulas in food processing. So, this used widely. The aqueous phase and oil phase can be breakdown due to Ostwald ripening. We already know that due to ripening process, this oil phase, aqueous phase, that can be breakdown, and this can be prevented by adding stabilizing agent which is called nano emulsion. That is mainly acts as emulsifying agent. That emulsifying agent as their work of the major function of this emulsifying agent is to uh, keep bounded both hydrophilic and hydrophobic bond that in between that one that hold together and preventing their separation. So that nano emulsions functions is like that one as a emulsifying agent, and that work in a different development of different food product or other. The stabilizers distribute on a particle can from either a monolayer, multilayer, and solid particulate nanoemulsion. That is properties of actually lipid that forming different types of the layer. Micelle also formed, and for that all that formation, this nano emulsion plays important role that keeping adhering both nano in case of mainly the in case of mainly in fats and oils. There is an both aqueous phase and oil phase is present that keeping that one hold it together. The stabilizers, also called emulsifier, reduces the interfacial tension resulting in formation of small and stable nanoemulsions. The emulsifier also prevent collision and coalescence between the droplets and increase the kinetic stability of the nanoemulsion. Some example of emulsifier are small molecule surfactant, phospholipids, proteins, and polysaccharides. So all that one in nano range that acts as a now application of these nano emulsions in food industry. This nano emulsion used in food industry for various purpose as that are incorporated with nanoparticles. Nanoparticles are antimicrobial, antioxidant in nature, so that helps in the that acts as antibacterial, antifungal agent, and that can cause the killing of the microorganism if that incorporated in the food. So the most wide application is their antimicrobial nature. Then texture modification, sometimes the texture which is not accepted, not in good condition. In that case, if specific nanoparticles, if added, texture becomes acceptable, and that can be easily accepted by the consumers. Again, flavor enhancement, sometimes we using additives, flavoring agent. That flavoring agent along with nanoparticles, that their effectiveness that increases. So in that case, that helps in enhancement of the flavor. Then nutrient enrichment, sometimes different nanoparticles which acts as a micronutrients for our body. So along with that food materials, if that incorporated, if that in goes inside our body, that provides some nutrition along with the other protective nature. Also used as coolant, provide stability to the component and also increase their bioavailability. So that enhance bio. So nano emulsion have potential application in food industry for the delivery of Nutraceuticals, coloring and flavoring agents, and antimicrobials, nanoemulsions have been used as a suitable form to improve the digestibility of food, viability of active components. The nanoemulsions formulation of active ingredients can be used for developing biodegradable coating and packaging films to enhance the quality, functional properties, and nutritional values and shelf life of the foods. So these are the applications of nano emulsions in food industries. Advantage and disadvantage of that one. Advantage of nano emulsion is that controlled drug release that protects a drug protection from degradation during process, so that protect drug from their degradation, that there is a high that shows very higher loading capacity, that provide greater stability, efficient carrier for hydrophobic drugs, low production cost. But besides there are lots of application advantages in food industry, there is a few disadvantages also there, and that are less permeability and viability of drug, low viscosity and speedability, no non-compatibility and skin irritability and others. So these are the advantage and disadvantage of nano emulsions. So another nanoparticles used is the liposomes, which are spherical vesicles characterized by bilayer lipids with an internal aqueous cavity. Because as you know that phospholipids that has two ends, polar head and non-polar tail. So polar head is towards the center, non-polar tail is toward the center and polar head is away from the center, that forming a group of this one fat, and that arranged in a form of this circle, which is normally called as liposomes, in which the centrally there is an this bilayer form, one layer of the on our non-polar end, which are the tail of the phospholipids, and another layer which is out on the surface, that are polar head of the lipid. So that being one of the most successful nutrient additive supplement delivery system applying nanotechnology. So these are the major. Here also nanotechnology plays important roles. And then application of liposomes are mainly used on texture alteration and water retention improvement. Liposomes can encapsulate various components such as additives, preservatives, and antimicrobials, resulting in enriched flavors and increased viability of the content. Liposomes are particularly suitable for food nutrients as they provide natural. So these are the application of nanotechnology in food industries. Okay, thank you.